In this example, we want to find the next three terms in the sequence in the equation for the general term. What we need to do first is figure out if this thing is arithmetic, geometric, or maybe it's not either one. We want to look and see if the common difference is the same between all of these terms. There's a few ways to do this. One, you can just reason and say, how would I get from 16 to 9? And that would be subtract 7. How would I get from 9 to 2? Well, still subtract 7. And then from 2 to negative 5, still subtract 7. Another way we could do this is take one term and subtract the previous term. So to find d, you can take any term, we'll say that's a sub n, and subtract a sub n minus 1. If we use this, let's pick the fourth term, so that would be a sub 4, which is negative 5, minus a sub, not the fourth term, it's the 4 minus 1, or the third term, which is 2, and that's negative 7. We can do this with any of these terms, and it should be the exact same value if the sequence is arithmetic. So for instance, we could do 2 minus 9, and that still gives us negative 7. So a couple different ways to do it if you're having a tough time figuring out what d is or if it's arithmetic or not. Just check and make sure that if you take one term, subtract the previous term, that works for all of them, or at least 2 or 3. So we know that d is negative 7. We want to find the next three terms here. So if we do that, we need to take negative 5, subtract 7, and that's negative 12. Negative 12 minus 7 is negative 19. And then negative 19 minus 7 is negative 26. So here's part of our answer right here. And then we want to find the equation for the general term. So we'll just box that in as part of our solution. And then a sub n is going to be a sub 1 plus d times n minus 1. That's our nifty formula for the general term. And we've got a sub n then. The first term is 16. Always go back to that original value here that we began the sequence with. And then we've got negative 7, and then in parentheses n minus 1. You could leave it like this. I think it's a little bit nicer to clean this up. And so we could do the distributive property, and a sub n then will be 16 minus 7n plus 7. A sub n then, if we rearrange our terms and combine like terms, we've got negative 7n, and then 16 and 7 is 23. So this would be a nice cleaned up version of the general term. What this is doing for us is we can get any one of these outputs or any one of these terms if we know the value of n, the index. And all we need to do is substitute that in, and we've got it. For instance, the, let's see, 1, 2, 3, 4, 5, 6, 7th term would be negative 7 times 7, which is negative 49. Negative 49 plus 23 is negative 26. So if you can find the general term, you don't have to go through this process, although if you want to find just the next three terms, it's nice and easy just to apply d every single time. It's known as recursion, or recursion is just basing the next value off the previous term. However, especially for larger values of n, this one's going to be the best one. Now, for some of you out there who are very familiar with linear equations, you're noticing that this is the same thing as a linear equation. The slope is negative 7, or the rate of change is negative 7. And if you look, the same thing we're adding every single time is negative 7. So really an arithmetic sequence is linear in nature. As a matter of fact, if you plotted these points with n being x, or like the input, and the output being these terms here, all the dots would line up in a straight line. Now you wouldn't want to connect those just because our index values need to be positive integers, and what is the 1/2 step wouldn't make any sense really at all. So be careful with that. Also, this 23, there's another way to get to it as well, and that's if you take 16 and then if you go backwards. So instead of subtracting 7, if we took 16 and added 7, maybe this would be like the 0 term, I guess, if that even existed, then that would be 23. So like 16 plus 7, or 16 minus negative 7 would be 23. And this is the same thing as the y-intercept. So when the input is 0, n is 0, you would get a 23 here. Although keep in mind that we want to start our n value at 1, then go 2, then 3, then 4. But that's just another way to think about it.